Welcome to Brain Vision.
In this problem, we are going to calculate the angular velocity omega AB at the given instant of time. So let's write the energies and work done corresponding to this system. So kinetic energy initial is written as a Ti, which is equals to 2 into 1 by 2 IAB omega ABI square. This is the initial angular velocity of this AB, plus 1 divided by 2 mb square. Here we can write the moment of inertia IAB as IAB is equals to 1 divided by 3 mabl square, and we can write this VB as VB is equals to L omega ABI square. L omega ABI. Now by inserting these two values into this equation, we can write the initial kinetic energy as Ti is equals to 2 square brackets open 1 divided by 2 into 1 divided by 3 MAB L square, and here we can write omega ABI square plus 1 divided by 2 mb into L omega ABI whole square. Now let's write the values into this equation. We can write this one as Ti is equals to 2 square brackets open 1 divided by 2 into 1 divided by 3. Then we have to write the value for this MAB as 8 lb divided by 32.2 feet per second square, and then here we have to put the value for this L, which is equals to 2 feet whole square, and then we have to write the value for this omega ABI, which is equals to 2 radians per second whole square plus 1 divided by 2, and then we have to put the value for this mass of the bar as 10 lb divided by 32.2 feet per second square, and value of L as 2 feet square, and omega ABI, which is equals to 2 radian per second whole square. So this will give us the value for this Ti as Ti is equals to 3.810 lb feet. Similarly, we can write the value for Tf by setting the value of omega ABI into above equation. By setting the value of omega ABI to omega AB into the above equation, so that will give us the value for this Tf as Tf is equals to 0.952 slug feet square into omega AB square. Now let's calculate the work done corresponding to this system. So the work done corresponding to the force P is written as UP, which is equals to 20 lb into 2 feet sine of 45 degree. So this will give us the value for this UP as 28.249 lb feet. The work done corresponding to the torque is written as UM, which is equals to m theta. So this is written as 15 lb feet into the angle, which is equals to pi by 4 radians. So this will give us the value for this UM as 11.781 feet lb. Similarly, we can write the work done corresponding to the weight of R as UWR, which is equals to minus 2 into 8 lb into 1 feet into 1 minus cosine of 45 degree. So this will give us the value for this UWR as minus 4.686 lb feet. Similarly, we can write the value for this weight of the bar, work done corresponding to the weight of the bar, as UWB is equals to minus the weight of the bar, which is equals to 10 lb into 2 feet into 1 minus cosine of 45 degree. So this will give us the value for this UWB as minus 5.858 lb feet. Now let's apply the work energy principle to the system. We can write that one as a sigma UI to F. This is the net work done corresponding to the system, which is equals to UP plus UM plus UWR plus UWB is equals to TF minus TI. Now let's put the values into this equation. We can write this one as 28.284 lb feet plus UM, which is equals to 11.781 lb feet minus UWR, which is equals to minus 4.686 lb feet. Then we have to put the value of this WB minus 5.858 lb feet is equals to TF, which is equals to 0.952 slug feet square into omega AB square minus omega TI, which is equals to 3.810 lb feet. From here we can write the value for this omega AB as omega AB is equals to 5.92 radian per second. So this is the required answer. Thank you.